So now we proceed to talk about positive and negative deviation from the ideal behavior. We have learned what is ideal solution, and then a solution may follow Raoult's law to a certain extent, or there may be a deviation. There can be deviation from the Raoult's law. And deviation in what respect? It depends, of course, upon the interaction of the molecules or the particles present in a solution. Now, if the vapor pressure of a solution is more than that expected from the ideal solution, then we say that the solution has a positive deviation. Why this positive deviation occurs, we have already learned. But again, I'll revise today. And then, if the vapor pressure is lower than that of the ideal conditions or ideal solution at a particular conditions of temperature and pressure, then it is known as negative डेविएशन फ्रॉम द राउल्स लॉ. यानी अगर वेपर प्रेशर ज्यादा हो जाए तो हम कहते हैं किससे ज्यादा हो जाए, आइडियल बिहेवियर से, आइडियल सोल्यूशन अकॉर्डिंग टू राउल्स लॉ, देन वी से इट इज ए पॉजिटिव डेविएशन, and if it is less we call it as negative deviation. Now this positive and negative deviation, as we know, again depends upon the interaction of the particles. Now what are those interactions? We need to go through it, and we have already an idea about the positive or negative deviation. So here is a chart I have prepared for you, that is under different columns: particle interaction, escaping tendencies, and deviation from the ideal behavior and their examples. Now, if the A-B interaction is lesser than AA or BB interaction, or in other words, when you say that solvent-solute interaction is lesser than the solvent-solvent, it may be AA or BB interaction, then what happens? The escaping tendency of the solvent particle, escaping means leaving the surface of the area, formation of vapors, it becomes more and it gets easily vaporized. Solvent particles, the escaping tendency is greater than the solute particles. जो चीज मिलाई गई है सल्फेट जो कम मात्रा में है, हमको तो ये तो मालूम है, a component which is present in lesser extent, that is known as solute. तो इसमें सॉल्वेंट का वेपर प्रेशर ज्यादा हो जाता है, वो वेपर प्रेशर बढ़ जाता है, and therefore we call it as a positive deviation. There is an increase in vapor pressure. Now, there are examples. A few examples are here, and it is provided in your book also. We shall go through the book shortly. That ethanol plus acetone. Ethanol, you know, is C2H5. When mixed with acetone, forms a miscible solution, binary liquid. Now, what happens? That ethanol, a liquid, there is a hydrogen bonding. And when acetone is mixed to it, what happens? That the particles of the acetone weaken the hydrogen bonding in ethanol. इथेनॉल में जो हाइड्रोजन पार्टिकल्स में जो हाइड्रोजन बॉन्डिंग है, एसीटोन मिलाने से वो हाइड्रोजन बॉन्डिंग कमजोर हो जाती है, एंड दैट्स व्हाई व्हाट हैपेंस दैट द वेपराइजेशन बिकम्स मोर. इथेनॉल इज इजीली वेपराइज्ड, द सॉल्यूशन वेपराइजेज इजीली, हाइड्रोजन बॉन्डिंग कम हो गई तो पार्टिकल का जो एस्केपिंग टेंडेंसी है वो ज्यादा हो जाएगी. इट्स देयर. सिमिलरली, another example is carbon disulfide and acetone, CH2 plus acetone. That also reacts the same way. Now, another example is there, that is solvent-solute interaction, AB interaction, solvent and solute. That means AB interaction, solvent-solvent interaction or solute-solvent interaction. AB interaction is greater, यानी सल्यूट सॉल्वेंट का जो पार्टिकल का इंटरेक्शन है वो ज्यादा है एज कंपेयर टू द सॉल्वेंट सॉल्वेंट और सल्यूट सल्यूट AAR-BB इंटरेक्शन से. देन व्हाट विल हैपन? सल्यूट सॉल्वेंट पार्टिकल्स AB interaction is greater than solvent-solvent and AA particles. So what happens? The escaping tendency of AB is more. AB यानी solution जो बना है वो ज्यादा vaporize होगा. Escaping tendency is the extent of vaporization of a particular component of a binary liquid, and that is known as vaporization. And in this case, what happens? The Raoult's law, the solution behaves, the vapor pressure decreases as compared to the ideal behavior, and therefore it is known as negative deviation. ये पॉजिटिव और नेगेटिव डेविएशन को हमें ठीक प्रकार से समझना होगा, बहुत जरूरी है, और इस पर क्वेश्चंस भी आते हैं. और इसका बहुत अच्छा एग्जाम्पल भी है, क्लोरोफॉर्म एंड एसीटोन. Chloroform and acetone, when mixed together, what happens? They form hydrogen bonding. Chloroform और acetone hydrogen bonding बनाते हैं. So is the case with phenol and aniline. Phenol is OH and aniline is NH2. So lone pair of nitrogen and hydrogen, the proton in OH, they interact together to form a hydrogen bond. तो जिससे कि वे वेपराइज नहीं हो पाता ज्यादा, एंड देयरफॉर देयर इज अ नेगेटिव डेविएशन. ओके.